Students, we will start the class in a while. We will be starting the class in a while. We are waiting for the other students also. You can just drop down your names for attendance purpose. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Students who have newly joined can just drop down their names for the attendance purpose. We will be starting up in a while. We will be starting in a while. Students are requested to drop down their names for attendance purpose. We will be starting in a while. So, okay, we will start now. See, we will start with the session 9 of atomic structure. Previously, we are done with some questions of quantum numbers. That is, we discussed about the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. Okay, so now we will be studying. See, first we will discuss the overview of the chapter. Discovery of fundamental particle is done. Atomic models is done. Thomson, Rutherford and Bohr's model we have completed. Spectral studies we have also done. And today we will deal about the uncertainty principle and the photoelectric effect. Okay, we will be completing this, and in the next class most probably we will be discussing the quantum model and the electronic model. Okay, so here if you see explanation for Stark effect. See, what is Stark effect? We were saying that the particular line that we were observing, the spectral line, was splitted into some lines due to the application of what? Electric field, right? This was what the Stark effect. And the Zeeman effect that we were discussing, the Zeeman effect was what? The Zeeman effect was when magnetic field was applied, this particular spectral line was splitted. Okay, so the Stark effect is the shifting and splitting of spectral lines of atoms and molecules due to the presence of an external static electric field. So let us say here that a nucleus is present, right, and the electron is revolving, right. So we cannot know the exact position of electron. Let us say first the electron was here, then the electron was here, electron was here, electron was here. So basically the electron is moving in this direction, if you see, right. So here if you see that there are many atoms and molecules. For example, if you are taking, let us say, hydrogen spectrum, so there will be many atoms of hydrogen there. So let us say that one atom is having electron at this position. I'll draw it again, just a second. One electron in one atom, electron is present on this side, and let us say this particular electron is present at that side, right? One on the left hand side and one on the right hand side. Now I am placing the electric field. Let us say this is the positive charge of the electric field and this is the negative plate of the electric field. Now as the electron are negatively charged, these are what? Negatively charged. These are also negatively charged, right? Electrons are negatively charged. So so they will tend to move towards the positive charge of the electric plate. Why? Because of the force of attraction between positive and negative charges, right? So there is a force of attraction basically on the positive and negative charges. Therefore, the electron tends to move towards the positive plate. Now what happens is, let us say that this electron will be moving further away from the nucleus because it is attracted by this plate. So this electron, it will be moving in this direction, right? It will move away from the nucleus. Let us term E1 and E2, right? So E1 is attracted by the positive plate and it is going away from the nucleus, right? While E2, if you see, it is going towards the nucleus. It will also move towards the positive plate. So it is moving towards the nucleus. So E2 is moving towards the nucleus. And we have already studied that greater is the distance of electron from the nucleus, greater is its energy, right? So here if you see that electrons is there, right? For example, this is the first shell, then we discussed about the second shell, then we discussed about the third shell. So we discussed that as we increase the orbit number, electrons energy is what? Increasing. So here also if you say that E1 is moving away from the nucleus, therefore its energy would increase now, right? While if you the E2 electron, if you say that it is moving towards the nucleus, so it will be more stabilized and it will have lesser energy. As I already explained you that energy is what? Inversely proportional to that of the stability, right? So E1 electron, if you see, it is moving what? Towards the nucleus, away from the nucleus. So it will have a greater energy, lesser stability. While E2 electron, if you see, it is moving towards the nucleus, therefore it is having less energy, right? So now the electrons are differing in energy due to their position. But when the electric field was not applied, so the distance of these electrons were same from the nucleus, and therefore only single line was obtained when electric field was not applied, right? While when electric field was applied, due to the difference in energies of E1 and E2 that was created, this particular line splitted into three by applying electric field. I hope it is clear. You can just check in the chat section box, type in the chat section box and let me know. Type in the chat section box and let me know, have you got the concept of that why there is a splitting? Let me know, all of you. I think there is a lag in the chat box. Let me see if you have understood this particular thing. I think there is a lag in the chat section. Clear? Okay, good. Okay. So next we will move on to see. An electric field pointing from left to right, for example, tends to pull the nuclei to the right and electrons to the left. This we have already done, that how the positive plate can basically tend to attract the electrons, and there will be a difference in energy of the electrons itself. Okay. So next, the concept is orbital angular momentum. See, what is basically orbital angular momentum? If you see, imagine a cycle, right? Imagine a cycle here. Yeah, pardon for my drawing capabilities are not good, right? Yeah, so this is basically a cycle, let us say, right? So first we will discuss about that what is basically a linear momentum, right? When the object is traveling in a straight line basically, so what happens is we define the linear momentum of an object, that we define it as what? Mass into its velocity. This is the linear momentum. When an object is in the circular motion, when the object is in the circular motion or in the rotational motion, then we will apply the concept of angular momentum. Because if you see that this is the particle, let us say, right, and this is moving in what? This is moving in circular direction. So can you see here that the angle is changing? Here what is changing? The angle is changing. Therefore, we define angular momentum for such objects which are having the circular motion as well as the rotational motion, right? So, with electron, if you see, there are two angular momentum associated with it, that is the orbital angular momentum and the spin angular momentum. So, let us see that what is the basic difference between a orbital angular momentum and a spin angular momentum with the help of a cycle. See here, for example, this cycle is not moving, right? I am only rotating its wheel. This particular wheel I am rotating, right? So it is basically rotating on its own axis. Now I make this cycle to move to a circular path, right? Now this cycle is going through a circular path. So this whole cycle is also moving in a circular path. Moreover, this particular tire is also moving about its own axis. Or you can basically refer the example of Earth, let us say, right? So if Earth is there, let us say this is Sun, and the Earth is revolving around it, right? The Earth is revolving around it. So this is the circular motion, that the Earth is revolving around the Sun. But Earth is also rotating about its own axis. You must have seen that 360-degree, you know, 360-degree in the, I think there is a name of a ride that is 360-degree in water parks and all. So what happens is that you are also moving, the seat is also moving, as well as that all the person inside that ride are also revolving around, right? Similarly, the Earth is also moving around its own axis, right? And also it is revolving around the Sun, right? So here if you see that when it is revolving around the nucleus, the electron, when it is revolving around the nucleus, it is known as orbital angular momentum. It is known as what? Orbital angular momentum. While when the electron is spinning itself, right, when it is spinning itself, just as the Earth is rotating along its own axis, so when the electron is moving around its own axis, then it is known as spin angular momentum of electron. So two types of angular momentum can be suggested for a particular electron, that is the orbital angular momentum that comes from when the electron is moving towards a circular motion in the around the nucleus. While when it is rotating along its own axis, it is known as spin angular momentum. So the magnitude of angular momentum, we assume that orbital angular momentum is root L into L plus 1 h by 2 pi, where L is what? The azimuthal quantum number, whose values are what? 0 to n minus 1, right? This is the azimuthal quantum number. And also here if you see, h is the Planck's constant, pi is having a value of 3.14, right? So I told you before also that h by 2 pi can be written as h cross also, right? So this particular formula can also be written as that orbital angular momentum is equal to root L into L plus 1 into h cross. Okay, remember that this h by 2 pi is not in the under root. Okay, only L into L plus 1 is in the under root. So value of h was what? 6.626 into 10 raised to the power minus 34 joule second, and L is what? The azimuthal quantum number. So here comes a question based upon this formula. For a d electron, that is the electron is present in the d subshell, the orbital angular momentum is what? Give the answer in A, B, C, D. Okay, Arun is asking, ma'am, electric current is flow of electron. Can you explain from that view, ma'am? I'm not getting your question. Which one are you asking? The first one? The Stark effect you are asking? See, the details of Stark effect you will also learn in class 12th basically. So if you want to correlate it with physics, that will be done in the physics class in class 12th. And for the meanwhile, for the better explanation of the Stark effect in terms of chemistry, you can understand it that way, that positive nucleus is there and the electron's energy change when we apply the electric field there, right? Due to the change in energy, now the two electrons, the transition will be of different energy, thus they are having different spectral lines. That means the particular spectral line gets splitted into various spectral lines. Now do the answer for this particular question and let me know. What should be the answer for this particular question? Let me know. Okay. A. Okay, Arun is saying A. What about others? What about others? Solve the question. You just have to apply the formula L into L plus 1 under root and then h by 2 pi. Okay, the Pashri is also saying A. What about others? I want answer from everyone because we have done quantum number in detail. A whole session was dedicated to quantum numbers. So you should be knowing that what is basically the L value for d electron. What is the L value for d electron? We know that S, P, D and F. So here if you see, L value for S is 0. For P it is 1. For D it is 2. For F it is 3. So what is the L value for D? That is basically equal to what? 2. Right. So here you can apply the formula what? 2 into 2 plus 1 into h by 2 pi. Right. So this will become equal to 2 into 3 h by 2 pi. That will become equal to root 6 h by 2 pi. Am I clear? I was expecting that all of you should get this answer. What about Anirudh, Sanjay, Jayanand? Have you understood the answer now? Yeah, so Arun and Dipashri, you are correct with the answer. The answer is A, that is root 6 h by 2 pi. Okay. Now, next we will move on to the spin angular quantum number will be having a value of s into s plus 1 h by 2 pi, right? Where s is the total spin value. Now we will understand that what is the basically total spin value. See, here if you see, let us say, for the time being I am saying that this is a d subshell basically, right, consisting of 5 orbitals. So I place one electron here, one electron here and one electron here. So we are knowing that the spin of one electron is what? 1 by 2. Then the spin of 3 electrons will be what? 3 by 2. Am I correct? The value of the total spin value will come out to be 3 by 2. That is half plus half plus half. So S will come out to be 3 by 2. And if you want to find out the spin angular momentum, then you can put the value of S and then you can find out the spin angular momentum. Question related to this we will be doing when we will discuss about the electronic configuration, that basically how particular electronic configuration is filled, right? So then we will discuss. Okay. So this is how you can find out the total spin value just by adding up the spins of electrons. Okay. Now next comes the dual nature, right? First we studied about the dual nature of light, that light can have a particle nature also and light can have a wave nature also, right? So here if you see, first we studied that that light is what? Basically a electromagnetic wave. What is a electromagnetic wave? It is a wave which is associated with the electrical components as well as the magnetic component. And the electric field, the magnetic field and the direction of propagation are mutually perpendicular to each other. So let us say that on x direction, if you are taking the direction of propagation, then y you will be taking the direction of magnetic field and then z you will be taking the direction of electric field. Okay. So electromagnetic waves are those kind of waves which are associated with electric and magnetic fields, and the direction of propagation, the electric field and the magnetic field are mutually perpendicular to each other. Now, here see that on the basis of interference, we can say that light has a wave nature. There are two phenomena, that is interference and diffraction. Interference and diffraction that can be explained on the basis that basically explain the wave nature of light. Now let us see what is interference, right? Here if you see, I am taking a laser light and I am making two slits here, right? So one radiation will be here and one radiation will be here, right? Now let us say that this is a wave. Let us say that this is a particular wave coming from one side, right? This is a particular another wave which is coming from the second side. When it joins this particular, that is the first radiation, in such a way that crest overlap with crest and trough overlap with trough, then it is known as constructive interference. Basically what interference mean is that interfering of two types of radiations, right? Here we are particularly studying light, so we can say that two radiation of light, maybe they are interfering with each other. So they can interfere in two different ways. Either they have a constructive interference, or they have a destructive interference, right? So first we are studying what is the constructive interference. So constructive interference is that kind of interference when the two radiations, the two electromagnetic waves overlap in such a way that the crest of one is overlapping on the crest of other, right? And the trough of one is overlapping on the trough of other, right? Similarly, if you see destructive interference, if you see destructive interference, let us take one radiation here coming from this side and one radiation is coming from this side. This I am drawing like this. Now see, can you see the second one? Crest of one radiation is overlapping with the trough of another. Can you see here? Crest of this, trough of this, crest of this, trough of this, crest of this, trough of this. So this is what basically a destructive interference, where crest and trough overlap, that is known as destructive interference. Where crest overlap with crest and trough overlaps with trough, it is known as a constructive interference, right? So in constructive interference, if you see, when the two rays join, when the two electromagnetic waves join, there is an increase in the whole amplitude. There is increase in the whole amplitude. So this has a physical significance. Let us say, at times when you pass over a bridge, your vehicle pass over a bridge, the bridge starts moving in up and down direction dangerously. So what is happening here? That the bridge is having a vibration, right? Let us say that the bridge is having this kind of vibration. Now we are taking the vehicle will also have its own vibration. When these two vibrations will overlap in constructive interference, then the bridge will be heavily moving up and down dangerously, right? So at that time you can particularly feel that the bridge is moving up and down. So this is an example of a constructive interference. Okay, I hope you could particularly understand this particular thing, right? So here if you take laser light, let us say, yeah, one more thing I forgot to mention, that it is in destructive interference there is a decrease in overall amplitude. There is a decrease in overall amplitude when two electromagnetic radiations interfere. While in constructive interference, there is an increase in the amplitude of the overall wave when the two waves interfere with each other, right? So this was interference. Now let us look at this particular thing, this diagram. Laser light, so one will be passing from here and one will be passing from here. So at times when they will have a constructive interference, they will show dark bands. At dark places, can you see this? They are having constructive interference, right? While at the lighter places, can you see that they are having a destructive interference? So this is how two electromagnetic waves can particularly interfere with each other. Now we will study about, yeah, see here, can you see here that the two waves are interfering with each other in such a way, and where there is a pattern of dark bands, you can see that constructive interference is there. Okay. So next we will study about diffraction. So one important real life example of diffraction is what basically, see, if you cast a shadow of a particular object, we know that a shadow can be casted by, subjecting that particular object to light, right? Without light, the shadow can't be casted. So here if you see that if the light was having particle nature, if the light was having particle nature, then the shadow that we should obtain should be fine at its edges, but here if you see that in practically it was observed that the shadow that was being casted was blurry at the edges, So the explanation was made that particularly the light or the electromagnetic waves have a wave character, that is why we are obtaining the blurred edges. Have you seen moon? Right, so moon is not having fine edges. If you see, it is having a sort of blurry edges, right? So this is the cause that it undergoes diffraction, right? The electromagnetic wave or the light basically undergoes diffraction. What is diffraction basically? If you see that the lights bend somewhat, right? The wave while passing through a medium, they bend at a certain angle. This is known as what? Basically diffraction. Okay. So we were having only a gist of interference and diffraction in our session, and the other things means the detail of interference and diffraction you will be studying in 12th. Okay, so that was all for diffraction. Now we come on to the Planck's quantum theory. So here we said that particularly if you see the diffraction and the interference phenomena, they can be explained on the basis of what? They can be explained on the basis of the wave nature of light, right? Planck, on the other hand, said that different atom and molecule can emit or absorb energy in discrete quantities only. That means in form of small packets. He said that this particular light radiation, if you see, it is made up of small packets arranged in a continuous manner. It is made up of small packets, right? It is not fully continuous, rather it is in a form of small packets. And he said that the smallest amount of energy that can be emitted or absorbed in the form of electromagnetic radiation is called a quantum. So he said that a particular radiation is made up of what? It is made up of small packets of energy, and one packet of energy is equal to h nu, right? One packet of energy is equal to h nu. The energy of that particular packet is equals to h nu. Okay. So they Planck said that instead of electromagnetic waves, that is the electromagnetic radiations, basically they are not in the wave form. Rather, he explained that they are in the form of packets, form of particles, basically, right? So this is the particle theory of light photons. We will just have a review because we have already studied the Planck one, right? We have already gained the idea of it. So radiation behaves as if it is made up of particles called photons, right? He said that the radiations, the electromagnetic radiations, are made up of small particles which are individually called photons. Each photon will have an energy equals to h nu and momentum equals to h nu by c, right? So what is momentum? Basically h nu by c, and speed c. We already discussed that value of c is what? 3 into 10 raised to the power 8 meter per second. That is the speed of light, right? So here we can also derive that E equals to h nu, and we know nu equals to what? C by lambda. So E is also equal to h c by lambda. This particular thing, formula, you have to remember. Okay. Now next point, he stated that all photons of light of a particular frequency nu or wavelength lambda have same energy and momentum. So obviously he said that if h is already a constant, right? If we take two radiations, let us say, for example, if we are taking two radiations, right, they are having similar nu, that means similar frequency, right? So energy, if you see, and they are also having the same lambda, if you say, right? So energy, if you see, is basically what? H nu, right? So h, if you state that h is already a constant for each and every radiation, right? For that is 6.62 into 10 raised to the power minus 34 joule second. So if you have made the frequency also same, then the all photons which are having particularly frequency nu and the wavelength lambda will have same energy and momentum. Okay, because these are parameters. If you make these differing parameters same, then the energy and momentum of each particle would be same. Next, this is very important point. Photon is the energy particle and so has no meaning at rest, right? That means the photon is always moving. It is the energy particle, right? It has no meaning at rest, or we can say that its rest mass is zero. So when you are talking about a photon, that means you are talking about a continuously moving particle, right? It has no significance at rest. Am I clear? Are the postulates clear? Let me know, is it clear till now? Shall I move ahead? Each and every point? Okay, so Arun, sorry, there was a lag in the chat box. I couldn't able to see your questions basically. Yeah, so I'll do one by one. Now, what about shell with both clockwise and anti-clockwise spin? See, particularly a shell is not having a spin, right? A electron is having a spin. Second question is, what will be the direction of light waves in constructive interference, right? They can be anything also. Here if you see, I explained you that they are coming from either sides, one from here and one from here. They can be coming from the same sides also. Here if you see, and here second radiation if you go, so if they overlap, such as that crest over crest and throw over throw, then you will get a constructive interference. Okay, and okay, third question was, yeah, that has already been answered, diffraction and refraction. So everyone is clear now? Is it clear till this part? Everything is clear. Shall I move ahead? Yeah, so next is, intensity of light is attributed to the number of photons. That means high intensity would be indicating more number of photons and low intensity will be the less number of photons. So if you see two bulbs, let us say that one it is glowing dim, right, and one it is glowing very intensely, right. So if it says that intensity of light is attributed to the number of photons. So if the number of photons is high, that means the intensity would be high. And if the number of photons is less, the intensity would be low. Okay, so Aryan is asking, what if a subshell occupies both electrons with clockwise and anti-clockwise spin? So the total spin gets 0. Here if you see, this is the clockwise spin and this is the anti-clockwise spin. So here it is plus half and here it is minus half. So total spin would be what? Minus half plus half. So the spin would come out to be 0 itself. Okay. Any more questions? Any more questions? Do you want to ask any more questions? Shall I move ahead with the postulates? Dipashri, Jayanand, everyone, is it clear? Sanjay, let me know guys, otherwise how will I be able to know that if this particular part is clear or not? See, resultant direction would depend upon the direction of okay, just a second. That is because the angular momentum of any closed electron shell is 0, right? Yeah, Dipashri, you are not angular momentum, that is the spin value, right? That is the spin value. So if you are considering the s orbital, let us say, so s orbital you are taking, let us say, 2 electrons here, right? If you are taking 2 electrons here, so total spin value is coming out to be 0. Now if you put what, the spin angular momentum for that particular s orbital, that will be equal to what, root of s into s plus 1 h cross, right? So now it will be 0 into 0 plus 1, that is h cross, that is equals to 0 only, right? So in that case it will be 0 if there are only 2 electrons present and there are and the one is clockwise and one is anti-clockwise. Okay, not the angular momentum, the spin angular momentum. So there are two types of momentum, that is orbital and the spin one. So for the spin one, if you say s equals to 0, then it would be spin angular momentum equal to 0. Okay, so Arun, your answer is, it depends upon, let us say that this particular thing we considered. Just a second. Yeah, this, can you see that the waves are in this direction. One is moving in this direction and the second one is moving in this direction. Now when they overlap, they will be together moving in the same direction. Okay, they will be together moving in the same direction. So that it would depend upon the direction of the two waves that are undergoing interference basically. Okay. Okay. So next we were on, yeah, intensity has already been done. Now this is also very important point. Photons are electrically neutral and are not deflected by electric and magnetic fields. He said that a particular photon is electrically neutral. Neither it is having a positive charge, neither it is having a negative charge. Therefore, it will not be deflected by electric and magnetic field because it is electrically neutral. Okay. Now, don't, yeah. So here if you see, in a photon particle collision, this was asked in some examination, pay attention to this. In a photon particle collision such as photon electron collision, the total energy and total momentum are conserved. However, the number of photons may not be conserved in a collision because the photon may be absorbed or a new photon may be created. Now what does this mean is, for example, let us say that there is a photon and there is an electron here, right? So photon and electron, let us say that they are colliding with each other, right? They are colliding with each other. So the total energy is conserved before the collision, and after the collision there is a similar energy, and also before the collision the momentum, and after the collision the momentum is also the same, right? But here occurs an anomaly that a number of photons may not be conserved in a collision. That means that if you say that number of photons were 2 before the collision, now after the collisions the number of photons can be changed, right? Either they may be decreased. How they may be decreased? Because the electron will absorb the energy of that particular photon, right? Or a new photon may also be created when energy will be given out of the particular electron. Am I clear? This point is very important. It was once asked in the examination. So this is how you have to pay attention to every postulate, right? And therefore question from these are also framed, okay, such as assertion and reasoning or true or false can be made from particular statements or particular postulates of a particle theory. Okay, so this you must be understanding that a particular photon and electron, when they are basically colliding, if you say, the photon can either transfer its energy to electron, the electron will absorb the energy of a particular photon, right? So the number of photon now after the collision will be less. But if you see here that this particular electron, if it releases some energy, it will release the energy in photon form only, right? So there will be an increase in the number of photons after the collision. Okay. Next, if you see the photoelectric effect, this is very important and it is asked in the examinations itself. It also, explains, this phenomena explains the particle nature of light. Yeah, so Arun, you are asking that what if two waves of opposite direction strikes with each other? See, what happens is that, let us say that this particular wave is moving. Let us say this particular wave is moving and this particularly joins, right? So this particular wave will be moving in this direction only and this particular wave will be moving in this direction only, right? The difference is that they will just increase the amplitude of the resultant wave, right? There will be an interference here, right? Am I clear now? I hope I am clear. Wave interference may occur when two waves that are traveling in opposite direction meet, then the two waves pass through each other and affects amplitude. Yes, this is also correct, but this is not necessary that they are traveling in opposite direction. They can travel in same direction also. For example, if you see that I am creating a wave here, then I am creating the second wave here, right? I am making this particular wave to overlap onto this particular wave, right? So this is how in the same direction also they can overlap with each other. It is not necessary that they are coming from the two different directions. Okay, your answer, your question or the fact that you have stated is also correct, but that is not necessary that they are traveling in opposite direction. They can be traveling from the same direction also, right? As we have seen in the laser light phenomena, right? They were coming from the same directions and interfering with each other. Okay. Have you got it now? Is it clear now? Okay, good. Yeah, so coming on to the photoelectric effect, if you see, photoelectric effect explains the particle nature of light, right? So if you see photoelectric emission, photoelectric effect was observed basically when light of suitable frequency was, illuminated a metal surface, that it was made to strike on a particular metal surface. Electrons were emitted from that surface, right? When light was made to strike that particular metal surface, electrons were emitted from that metal surface, and these electrons which were emitted from the metal surface are known as photoelectrons. Why they are known as photoelectrons? Because these are the electrons which are generated by light, right? Which are generated by photons basically, right? So these electrons are known as what? Photoelectrons, which are being emitted from the metal surface itself. Okay. Now, by exposing radiation such as gamma rays, X-rays, UV rays, we have already done this, that these are type of electromagnetic radiations. I told you a mnemonic about it. You can remember it as Rami, Books, Geeko, right? Where radio wave, microwave, infrared wave, UV visible waves, X-rays, gamma rays and cosmic rays, all are what? All are electromagnetic radiations. So by exposing these radiations with a frequency higher than the suitable value, that is the threshold limit. Now this is the new term that we need to pay attention on, right? For example, let us say that a particular metal is there. Let us say that I am taking lithium here, right? So it is having a threshold value of let us say 2 electron volt. Now what does this 2 electron volt mean? That means that the minimum energy required by this lithium metal to eject electron from its surface is 2 electron volt. So when you are striking the metal surface with a particular radiation who is having an energy greater than that of 2 electron volt, then only the electron will be ejected. If you are supplying the energy of 1 electron volt, then the particular electrons will not be emitted now. The photoelectrons will not be emitted now. Now, if you provide 2 electron volt energy to the lithium, then the electrons will start coming out of the metal, that is lithium. Now, if I say, let us say that the threshold value is 2 electron volt. What does that mean? That the minimum energy that is required by that particular metal to eject electrons from its surface is known as what? The threshold energy value. Okay. So, now the question arises, let us say that lithium is having a threshold value of 2 electron volt, right? So, if you are giving the value of 1 electron volt energy, the electrons will not be emitted. Now let us say the lithium is having 2 electron volt. I give the energy of 2 electron volt. Now the electrons will be started ejecting, right? So the photoelectrons. What will happen when the energy of 3 electron volt or 4 electron volt or 5 electron volt, basically the energy which is greater than that of the threshold limit will be striking the surface of lithium. Now what will happen, that this extra energy will be absorbed by the electrons that were being emitted, right? See here, if I am applying 3 electron volt, right? So out of 3 electron volt, 2 electron volt will be used to eject out the electrons, and the extra 1 electron volt will be used to increase the kinetic energy of this photoelectron. Is it clear that where does the extra energy go? It is used to increase the kinetic energy of the photoelectron. Okay, so here if you see, yeah, let us say that the threshold frequency is mu naught, let us say, right? So I am bombarding or basically making the metal strike with a particular radiation whose frequency value is less than that of the threshold frequency value. So what will happen now? No emission of photon will take place. Now let us say that the value of threshold frequency is nu naught. Now you are making the metal strike with a frequency which is exactly equal to that of the threshold value. Then the electrons will be starting emitting, right? But if you take the frequency which is much higher than that of the threshold value, then the electrons will be emitting with the greater energy. Can you see here? These are with the less energy, these are with the greater energy, because the extra energy is used up to increase the kinetic energy of photoelectrons. Okay, so the number of electrons emitted out in this process depend upon the intensity of radiation. So if you increase the intensity of radiation, I already told you what is intensity, basically amplitude square, right? So if you increase the intensity of the radiation, the number of electrons, the number of photoelectrons that are coming out will be greater. While if you increase the frequency of the radiation, then the speed of the photoelectrons will be increased, as there is a increase in the kinetic energy of the photoelectrons. I hope I am clear with the concept. Okay. So now this phenomena particularly was successfully explained by Albert Einstein on the basis of quantum theory of light, and he also won a Nobel Prize in 1921, right? He was able to justify that why this particular phenomena, that is striking a metal with the radiation and coming out of photoelectrons, can be explained. He said that photoelectric effect is because of absorption of a light quantum photon by an electron. So he said that light is made up of, it was pre-known that the light was made up of what? The small particles, right? Small photons. Planck suggested that it is not a wave, actually light is made up of small particles known as photons, right? So he said that this particular electrons which are present in the metal atom, let us say, they absorb the energy of photons. They absorb the energy of photons. When they will absorb the energy of photon, they will be able to move out of the nucleus, right? We have already learnt about the ionization energy, right? That you have to provide much energy to that particular electron to, you know, pull that particular electron out of the nucleus. So it is similar to that only, right? You have to break the electrostatic force of attraction between the nucleus and the electron of a particular metal atom. So what you will do, you will provide some energy to this, break the electrostatic force of attraction between the nucleus and the electron, and these electrons now come out of the metal surface as photoelectrons. Okay. So now these are the postulates. At a given instant, each electron can absorb only one photon. This is important, that one electron will absorb only one photon. This particular electron can absorb only one photon. This will absorb only one photon, right? It will not absorb more than one photon. Now, it depends. See, we have already seen that E equals to what? H nu, where nu is the frequency, right? So, if I increase the frequency, that means I will increase the energy of the photon, right? So, if the energy of photon is more than the work function, that electron would be ejected from metal surface, else it would release energy to the surroundings, right? So, this is important. See, what is work function basically? If mu naught is the threshold frequency for a particular electron to come out of that its parent atom or its parent metal, basically, if mu naught is the frequency, then h nu naught is known as the work function. It is known as the work function. That is the minimum amount of energy that is particularly required by that electron to escape out of its parent atom, right? So now the energy that you are providing, that is the photon energy, is equal to h nu, and h nu naught is what? Basically the work function, that is the threshold energy, or it is also known as the work function, right? If h nu is greater than h nu naught, then only the electron will be ejected from the metal surface, right? If the if the h nu is not greater than, it is less than the work function, that is the threshold energy, it will just release the energy to its surroundings. It will release the energy to its surrounding, it will not come out of the atom now. Okay. So, we already studied that if you are providing the energy to that particular metal atom greater than that of the threshold energy, then the rest of the energy is used to increase the kinetic energy of that particular photoelectron, right? So, here you can write that if you are making the metal plate strike with that particular radiation, which is having a energy as h nu, right? Where each particle, each photon is having a energy of h nu, and h nu naught is the threshold energy, that is the minimum energy required for the photoelectrons to be emitted out, right? So the out of this particular h nu, h nu naught will be used to uh, eject out electrons from that particular metal surface, and the rest energy, because h nu is greater than h nu naught, the rest energy that is left will be converted into kinetic energy. So you can write down this particular formula, that h nu equals to what? H nu naught plus kinetic energy. Or you can, if you want to find out the kinetic energy of the photoelectron, you can just rearrange the equation and find out that kinetic energy equals to h nu minus h nu naught, right? Where h nu is what? The energy of the photon that is being incident on the metal surface. H nu naught is the threshold frequency, or it is also known as what? The work function, and this is the kinetic energy of photoelectron, which is basically given by what? Half mv square. Half mv square. So, photoelectric phenomena basically explains that the wave radiation, the light radiation, right, the electromagnetic radiation is in the form of particles and not a wave itself. Okay, I hope I am clear. Yeah. So work function, that is h nu naught, can also be written as phi naught. The work function h nu naught can also be written as phi naught, right? So in examination, either h nu naught can be given or phi naught can be given. So you have to remember that these are one and the same thing. Okay. Now here you can see the work functions of some metals, right? For lithium, the threshold energy is 2.42 in electron volts, the work function is 2.42. For sodium it is 2.3, for potassium it is 2.25, for magnesium it is 3.7, copper it is 4.8 and silver it is 4.3. Now what is the inference made from this particular table is that if you see, these are the characteristic value. The work function is characteristic of a particular metal. Characteristic of a particular metal. Right. So, metals, different metals will be having what? Different work function. Right. Is the concept of photoelectric phenomena done? Is it clear with you? You can just let me know in the chat section box first. And then we will try ending up this particular session. Yeah. Do you want to ask some questions? Okay, good. What about others? Jayanand, Sanjay, Anirudh, all clear? Okay, so we will end up the session for now. Thank you to all. In the next class, we will be discussing the Heisenberg uncertainty principle, right? So, for today, it's all. Happy learning.